Hi, grade 12s. How are you holding up? Good job on your tests. Hopefully it wasn't too horrible and you guys have a little bit of preparation for first year university. And hopefully first year you won't be distance learning. How are you guys finding this stuff? Hopefully you're paying attention to it. Are you confused? If you are, that is perfectly okay. We're going to get you through it because students do tend to have trouble with these. I mean, some people get it right away intuitively, and others, you just need a little bit of help. Okay, so let's go and let's label all of the super easy oxidation numbers. This is 2+. Guess what? This is also going to be +2. So all of the ions, sorry, I'm working on page 497, number 31. We're balancing this in acidic solution. So iron is 2+, its oxidation number is +2. Chromium is 3+, its oxidation number is +3. And then iron is 3+, and then oxidation. So you might be wondering, why am I switching the plus? It really doesn't matter. It's just a little bit of 4. This is the one that you need to do some calculations, okay? The whole thing needs to be equal to -2, the whole chromate polyatomic ion. There are 7 oxygens, which means that there is -2 times 7. So there is a total of -14 coming from just the oxygens, or sorry, like the oxidation. I can't explain it in better terms than that. What number do I need to, if I have -14 and in total I need -2? Well, if I have +12 minus 14, that's going to give me -2. I have 2 chromate ions, however. So I'm going to divide it by how many I have 2 chromiums and 1 chromate ion. I'm going to divide it by 2, and now I know that oxygen always is -2, and then chromium is +6. And since I'm working on a technology, I can disconnect them. Et voila. So that's how, if you need to rewatch how I did that, go do that now. And now let's connect the ions to ions. Do not be alchemists. Do not connect chromium to iron and it magically changed our iron to chromium. I'm connecting chromium with chromium. Okay, so chromium went from +6 to +3. Its number was reduced. So it is gain of electrons, reduction. So it is reduced. Therefore, it is the oxidizing agent. You don't have to write this down, but just for the sakes of purposes. And it's +3 electrons, okay? Iron obviously has to lose electrons, loss of electrons, and guess what? Its number is going from +2 to +3. It's increasing by 1 electron. Okay, so I have +3 minus 1. What do I do to get them equal? I multiply it by 3. So I have to put coefficient 3. I have a 3 here. I have a 3 here. So everything involved with having this multiplication of 3, I have to add a coefficient of 3 in my unbalanced chemical equation. Speaking of which, okay, what color am I going to do? Just going to switch to black. Cr2O7 2- plus 3 iron. Give yourself some space, because now we are going to be balancing. This case, it's in acidic solution. Okay. Do you notice how there's not even any oxygen in the balanced chemical equation, even though chromate has 7? Let's fix that. So if I have 7 oxygen, the only thing that I can do is add water to get oxygen. Oxygen has 1 water has 1 oxygen, and if I need 7 of them, I'm gonna put 7. Okay, this is still not balanced though, because I've now added water, I now have hydrogens. How many hydrogens? 14. So because there's this 14 hydrogens, that's it being balanced in acidic solutions. That's it, you're done, okay? So let's look at B. If you have I2 plus nitrate gives iodate plus nitrogen dioxide. This is in its elemental form. It's Hofbrinkel 0, okay? Oxygen is always -2. So let's figure it out down here. I have a total of -6 charge coming from the oxygen. I have to have a charge from nitrogen that's going to be combined with -6 to make it -1. It's going to be +5. +5 minus 6 is -1. So my oxidation number is +5. We have to do the same thing over here. Oh, look at beautiful oxygen, it's everywhere. Starting with, let's do nitrogen dioxide. You can see there's 2 oxygens, so the total is -4, so then nitrogen has to be +4 charge. Iodate over here, you have -6 coming from the oxygen. You have -1 being the total charge of the iodate ion. So iodine has to be +5 because +5 minus 6 is -1. Let's do our gain of electron, loss of electron. So again, I'm going to connect. See how oxygen doesn't change? It's -2, -2, -2 everywhere. It's not being either reduced or oxidized. So I'm not going to have any arrows being drawn for my oxygen. But my nitrogen and my iodine, some interesting things are going on. Iodine goes from 0, and its number is increased, not reduced, to +5. So because its number is increased, it is being oxidized. So it's loss of electrons, oxidized. 5 electrons. Okay. Nitrogen better be reduced, otherwise we did something wrong. And guess what? It goes from +5 to +4. It is being reduced. So GR. And it's being reduced by 1 electron. How do I get these two numbers to match? I multiply this one by 5, so 5 electrons. So everything here needs to have a coefficient 5. This is not balanced though, right? So we're doing some weird things. So let's go down here. So the most important thing is, the first step is to balance the electrons, which is what we did in this first step here. Now we have to, we're breaking the law of conservation of mass and matter because it's not balanced, and there's there's more products or more reactants. So let's figure it out. We have, for instance, I2 versus IO3. Sorry, so up here we have to account for that as well. So I need to have a 2 here. So that means this is actually going to be 10 electrons, right? So I have to multiply this by 10. I didn't even notice that until this part. I have to use coefficient 10 because breaking apart that diatomic molecule, you need to have 5 electrons for each iodine to form 1 iodate. So, oops, I forgot to do that. But you guys get to see the process, okay? Because I can't just put a 2 in front of here and say that it's balanced, because that iodine is participating in the redox reaction. It's each iodine here is taking, or sorry, it's losing 5 electrons. I think I said gaining earlier. So I have to account for that with the 10 nitrogen trioxides, or sorry, this is nitrate, and the 10 nitrogen dioxides. Okay, so what are we going to do now? We have to balance, you always balance oxygens first with water. So oxygens on my reactant side, I have 30. Oxygens on my product side, I have 6 plus 20 equals 4. Sorry, I'm skipping steps. I have 26. So I need, to get to 30, I need 4 more. So I'm going to put 4 H2O. Because you added water, you're also adding hydrogen. So you need to add the hydrogens over here as hydrogen ions, and that's why it is acidic. Okay, try C on your own. The answers are in the back of the book, so feel free to look at them there. 32. A. What's different about these redox reactions? They're in basic solutions. And so remember, basic solutions, you will not have an appreciable amount of hydrogen dissolved in the solution. Oh, if you hear some buzzing, there's a chainsaw or something in the background. Okay, so let's start off by marking down what the charges are. So chlorine over here is -1. Oxygen is -2. Total of -8. So I need chromium is going to be +6. Oxygen's -2. I need to have +1 charge to equal -1. And oxygen is -2. And I need to have +3 charge here. So let's connect oxygens. I mean, sometimes oxygen is reduced or oxidized, but most of the time, almost all the time, it is not. So I'm going to connect chlorine with chrome. Chlorine with chlorine, chromium with chromium. Chlorine, its number is increased. That means it is oxidized and it loses electrons. How much? It goes from -1 to +1, -2 electrons. Chromium, it better be gaining electrons. It goes from +6 to +3, so +3 electrons. I hope you guys are good at lowest common multiple, because we need to have the lowest common multiple is going to be 6. So I'm going to have coefficient 2 here. Multiply this by 3 to get to -6. So I'm going to have coefficient 3 and 3. All right, so make sure you give yourself lots of space over here and make sure you have an eraser. Okay, so the first thing we're going to balance is our oxygens. Over here I have 8 oxygens. Over here I have 3 plus 4, I have 7 oxygens. So I only need to add 1 here. But now I added hydrogen. I added 2 hydrogens. The way that you get rid of it is if you have 2 hydrogens here, you're going to have +2. You're going to add 2 hydroxides, which makes it 2 waters. Because you have added 2 hydroxides on this side to form 2 water, you have to add 2 hydroxides on this side. So I'm going to repeat that step again so that everybody can understand what I did. I added 1 water molecule here to account for the 1 oxygen that I need to balance. I can only add water. Because of that, I had 2 hydrogens that were added, so I have to add 2 hydrogens over here. Because it is in a basic solution, those 2 hydrogens, I'm going to balance out with 2 hydroxides, which gives me 2 waters. Because I just magically added that, I have to add it over here as well. These 2 waters and this water over here, guess what? I can get rid of this and make this 1, right? Because if I have 2 on the reactant side, 1 on the product side, I can just get rid of the 1 on the product side and reduce both numbers. So then I have 3 chlorine plus 2 chromate plus 1 water gives me 3, what is that, perchlorate plus, or sorry, hypochlorite plus 2 of these plus 2 hydroxides. This is my balanced chemical, or my balanced redox reaction. Okay, so again, I just want to double check. I make mistakes on these all the time. Which one am I making you guys do? 32A we're working on, and I'm looking at page 503. So 32A, 3 chlorine plus 2 chromate plus water forms, right. Yeah, everything's good. Okay, so again, check your work on page 503. Did you notice basic solutions? They're pretty much the same other than this step here and here, so that you should not have any hydrogens on its own in the final answer. Okay, they should all be balanced out with hydroxides and water. All right, take care. I hope that this makes sense. If not, rewatch it. Maybe watch some of the other videos that I posted. Good luck.